current electricity. Today, we will discuss important multiple-choice questions on current electricity 1. A steady current is flowing in a conductor of non-uniform cross-section. The charge passing through any cross-section per unit time is A. Directly proportional to the area of cross-section. B. Inversely proportional to the area of cross-section. C. Proportional to square of the area of cross-section. D. Independent of the area of cross-section. Correct answer, independent of the area of cross-section. 2. When current I flows through a wire, the drift velocity of the electrons is v. When current 2I flows through another wire of the same material having double the length and area of cross-section, the drift velocity of the electron will be A. v over 4, B. v over 2, C. v, D. 2v. Correct answer, v. 3. If the length of a wire is doubled and its cross-section is also doubled, then its resistance will A. Become 4 times, B. Become 1/4, C. Become 2 times, D. Remain unchanged. Correct answer, remain unchanged. 4. The specific resistance of a wire A. Varies with its length, B. Varies with its cross-section, C. Varies with its mass, D. Does not depend on its length, cross-section, and mass. Correct answer, does not depend on its length, cross-section, and mass. 5. The electric intensity E, current density J, and conductivity sigma are related as A. J equals sigma E, B. J equals E over sigma, C. J times E equals sigma, D. J equals sigma squared E. Correct answer, J equals sigma E.
For which of the following dependencies of drift velocity Vd on electric field E is Ohm's law obeyed? A. Vd proportional to E. B. Vd proportional to E squared. C. Vd proportional to square root of E. D. Vd equals constant. Correct answer, Vd proportional to E. 7. The resistance of a wire of uniform diameter D and length L is R. The resistance of another wire of the same material but diameter 2D and length 4L would be A. R divided by 4, B. R divided by 2, C. R, D. 2R. Correct answer, R divided by 4. 8. The resistance of a wire is R. It is cut into 4 equal parts, and all the parts are bundled together side by side. The resistance of the bundle is A. R divided by 16, B. R divided by 8, C. R divided by 4, D. R. Correct answer, R divided by 16. 9. A cell of EMF E is connected across a resistance. The potential difference between the terminals of the cell is found to be V. The internal resistance of the cell must be A. 2 times E minus V times V divided by R, B. 2 times E minus V times R divided by E, C. E minus V times R divided by E, D. E minus V times R. Correct answer, E minus V times R divided by E. 10. 5 cells, each of EMF E and internal resistance R, are connected in series. If by mistake one of the cells is connected wrongly, the equivalent EMF and internal resistance of the combination are 1. 5E, 5R, 2. 3E, 5R, 3. 5E, 3R, 4. 3E, 3R. Correct answer, 3E, 5R.